Okay, now we're going to look at two different compounds, benzene C6H6 and acetylene C2H2. And we're going to see that the ratio of carbon to hydrogen in this compound is 1:1, and carbon to hydrogen in this compound is 1:1. So on a mole basis, they're 1:1 equal. What we'll see on the mass basis is because they're the same ratios, two different compounds will have the same mass composition. So once again, we calculate the molar mass of 1 mole of benzene and the molar mass of 1 mole of acetylene, and then divide the mole fraction of each one component into the total mass. So I have 6 carbons in benzene and I have 6 hydrogens, which is 6 times 12.01, which is 6 times 1.007, which is equal to 72.06, and this is equal to 6.042. And if I have 1 mole of benzene, I have 72.06 grams of carbon, 6.042 grams of hydrogen, and a total mass of 78.10 grams. So when I divide the 72 into the total mass, it becomes 0.9227 carbon. When I divide the 6.04 into the total mass, it becomes 0.0773 hydrogen. So this is equal to 92.3% carbon and 7.7% hydrogen. Now I go over here for the second compound, and I have 2 moles of carbon and 2 moles of hydrogen for every mole of acetylene. So I have 2 carbons, 2 hydrogens, which is 2 times 12.01 and 2 times 1.007, which is equal to 24.02 and 2.014. So every mole of acetylene has 24 grams of carbon, 2 grams of hydrogen, and when I add these up, I come up with 26.034 grams per mole of acetylene. If I divide the 24 into the 26, I get 0.9227 carbon. And if I divide the 2 into the 26, I get 0.0773 hydrogen. And this gives me 92.3% carbon and 7.7% hydrogen. And I see that even though the masses are different, the fractions are the same, and both benzene and acetylene have the same mass percent composition.